All right, guys, today we're going to be covering 7.7 Law of Sines. Our depth of knowledge today is a level 4 of 4, and our learning target is I can use the Law of Sines to find missing sides and angles of a triangle. So, the first thing I want to mention for the Law of Sines is that this does not need to be a right triangle in order to solve for any sides or any angles within it. This can be used for any triangle that we run into. So, if we think back to what we've been doing so far, we've been using SOHCAHTOA to solve for missing sides and missing angles. For example, this first one, we're just going to go through it with what we currently know. So what we currently know is SOHCAHTOA, so our trig functions and our trig ratios. We're going to find all the missing sides, and angles of this triangle here. Now I already know that we have one angle, angle B, it's 90 degrees, which allows us to use our trig functions as of SOHCAHTOA. So if I'm going to solve for this, the first thing I'm going to do is I'm going to notice that sine of angle A is equal to 0.5. Well, if that's the case, then I know that we can solve for side length A and side length B using trig. Well, sine is equal to opposite over hypotenuse, and 1/2 is the same as 0.5. So therefore my opposite side is 1, my hypotenuse is 2. Next, if I use the same trig function, sine of angle A equals 0.5, I can solve for angle A. I just need to get rid of sine. And how can I get rid of sine? Well, I can take the inverse sine of both sides. Doing that will leave me with angle A equals the inverse sine of 0.5, which is 30 degrees. If you enter that into a calculator, you'll get 30. Well, by the no choice theorem, if angle A is 30, angle B is 90, that means that by the no choice theorem and the angle sum theorem of a triangle, angle C has no choice but to be 60 degrees. The last side that we need is side length C. That's the adjacent side to angle A. So if I focus in on angle A, C is adjacent. Well, which trig function uses adjacent? Cosine. Cosine of angle A is equal to adjacent over hypotenuse. We already know that our hypotenuse B is equal to 2. This shows us that our adjacent side is equal to radical 3. So therefore C is radical 3. That is how we used to do it. Today we're going to find a much easier way to go through these. And again, what we're learning today, you do not need a right triangle in order to solve for. So what we're learning today is the law of sines. This is for any arbitrary triangle. And the first thing I really want to point out is the triangle itself and how it's labeled. And this is how all these triangles will be labeled for you guys. So if they give you side lengths and angles and you need to draw your own triangle, this is what you would do. So if I look at angle A, first off, we have triangle ABC here, named by the angle measures. Now, to name side length A, it's always going to be opposite of angle A. Side length B will always be opposite angle B. And side length C will always be opposite angle C. So that's the first thing that we need to know, is that the side lengths will always be opposite their corresponding angle. So it's always going to be opposites together. In fact, when you're going through these problems, you can even sometimes circle them if that helps you out. That may help you in seeing what goes with what. Now, the law of sine says that if I take the ratio of sine of angle A and divide it by side length A, it'll be equal to sine of angle B divided by B, which is equal to the ratio of sine of angle C divided by side length C. So this will hold up, and we'll actually prove it in just a little bit. But what this allows us to do is solve for any missing side lengths or angles within any triangle. In fact, you'll notice that with the law of sines, what we'll cover in the next video, the law of cosines, and then finding the area of any triangle, You do not need it to be a right triangle to do these types of laws. These will work with any triangle, and that's very important to know. So you may be wondering, when am I going to actually use these? When do I know when to use the law of sines or the law of cosines? And we'll cover when to use the law of cosines in the next video, but for the law of sines, there's 3 specific instances. And of course, you're always going to be looking for opposite pairings. If you have those opposite pairings, as we see here, it's very easy to set up your trig ratios, especially with the law of sines. Law of cosines will be a little bit more difficult, but that's for another video. So, when to use law of sines? There's 3 instances. The first one is when we have 2 sides in a non-included angle. Again, included means that it is in between. Non-included means that it is not in between the other 2 pieces of the triangle. So if we have 2 sides in a non-included angle, we use law of sines. For instance, we have an example right over here. I have side length AB and AC, and then I also have angle C. Angle C is not included because it is not in between the 2 side lengths. So this is a non-included angle. So the way that I would set up this trig ratio would be sine of 70 degrees over 12 is equal to sine of angle B over 10. And that would allow us to solve for angle B. So this is one instance of being able to use the law of sines, if we have 2 sides in a non-included angle. The next way is if we have angle side angle, 2 angles in the included side. So this is the next way that we can use law of sines. Now for this one, we'd need to go ahead and do a little bit of math before we can actually set up law of sines. By the no choice theorem and the angle sum theorem of triangles, we can find out angle E. 50 plus 39 is 89. 89 plus what will give me 180? Well, 91. So angle E is 91 degrees, meaning our law of sines would be sine of 91 degrees. Whoops, should have been in purple there, or pinkish. Sine of 91 degrees over 13 equals sine of 39 over f, which is also equal to sine of 50 over d. I may need to erase that last one so that we can see our last type of when to use that, but this trig ratio should work. And again, I'd be doing it in 2 separate problems. I'd solve for f first, and then I'd use the same trig ratio, the same law of sines, to solve for d next. So let me go ahead and rewrite this a little bit so that you can see it a little bit easier. So we have sine of 91 over 13 is also equal to sine of 50 over over d, my bad. So again, we have those 2 trig ratios to set up to solve for our missing side lengths. And then our last instance of using law of sines is if we have 2 angles in a non-included side. Angle, angle, side. Let me go ahead and erase this last trig ratio down here. So this is the last instance of using law of sines. Our law of sines for this one would be sine of 40 degrees over 22 equals sine of 50 degrees over I. So that is how you guys would be using the law of sines in order to set up your problems. Now, once we have our trig ratio set up, it creates a proportion. And we know how to solve proportions. The way that we solve proportions is first we cross multiply, and then we solve our equation. So let's go ahead and see our first example here. Find all angles and sides of triangle ABC. They give us B is equal to 10, angle B is equal to 65, and angle C is equal to 29. Now, sometimes they won't give you guys this picture. They won't tell you the side lengths. They'll just give you triangle ABC. You'll need to draw it up yourself based upon just this given information, no picture. Make sure that you realize that the side length 10 will be opposite the angle 65 degrees. Very important when you guys set that up because that allows you to see the law of sines occurring. Now, from here, I have two angles and a non-included side. So we have angle, angle, side. The first thing I'm going to do is I'm going to use the no choice theorem to solve for angle A. Because if I solve for angle A, then we've already found out one of the angles, and then we can set up the law of sines for each of these. So therefore, 65 plus 29 will give me 94. 94 minus 180 will give me 86 degrees. So angle A is equal to 86 degrees. I'm going to use that information to solve for side length A, little a, which of course is segment BC. So to solve for little a, I'm going to have sine of angle A over A equals sine of angle B over B. Plugging in the actual values that we have for our angle measures and our single side that we have currently, we'll be left with sine of 86 over A equals sine of 65 over 10. From here, we can solve for our missing angle, our missing side length. And my tip here, do not multiply, do not convert these into decimals, the sine functions, until the very end of your problem. If you do it beforehand, you're going to have lots of decimals and lots of room for error. If you save it till the end, you should be good to go. So we enter this into we cross multiply. This will give us 10 sine of 86 equals a sine of 65. Now, don't forget that sine of 65 is just a number. It's a very small number. In fact, let me go ahead and enter it in on my calculator. Sine of 65 is 0.90630, and then repeating, or not repeating, but continuing on forever. So this is just a number. So I have a times a number. Well, how would I typically get rid of a number with multiplication when I'm solving for a variable? We would divide. So I'm going to divide both sides by sine of 65, leaving me with a is equal to 10 sine of 86 over sine of 65. This is what we're going to enter into our calculator. And make sure that you guys put parentheses around this. I'd suggest putting parentheses around the bottom, and you should be good, but make sure that you guys are entering it in, parentheses and all. Entering this into our calculator will give us a is about 11. Now that we solve for a, the only other side that we need is side length c, little c over here. So we're going to use the law of sines once again. So this time I'm going to have sine of 29 over c equals sine of 65 over 10. Same thing, we cross multiply to solve. So we're going to be given c sine of 65 equals 10 sine of 29. At this point, we want to get c by itself, so I divide both sides by sine of 65. That'll leave us with c is equal to 10 sine of 29 over sine of 65. This is what we want to enter into our calculator. Again, do not forget your parentheses. Forgetting parentheses will cause you to get the wrong answer. Also, please make sure that your calculator needs to be in degrees. If it's not in degrees, then you're not going to get the correct answer either. Make sure it's set in degrees. If you're not sure how to do that, please contact me. When we enter this into our calculator, we get our final answer as c is about 5.35. And that is our final answer for this problem. Now, you may be wondering, how come this always works? What caused it to always work? And we have a proof for it, actually. So here's our law of sines proof. This is why the law of sines will always work for us. And you don't need to know this proof for the test or anything, but it is still important for you guys to see. So if we look at this, first off, we see that we have a triangle ABC, and sides are all labeled. Opposite of angle B is side length B. Opposite of angle A is side length A. And opposite of angle C is side length C. Now, on top of this, we see that it is a right triangle, triangle ABC, and we also have an altitude on the hypotenuse. So what this creates is it creates three right triangles, the small, the medium, and the large. So I'm going to go ahead and set up trig ratios for angle A and angle B. And since this is law of sines, it's going to be the sine of those angles. So if I focus in on the small triangle first, Sine of angle A is opposite as H. Hypotenuse is B. So I have sine of angle A equals H over B. Next, I focus in on angle B. So sine of angle B, well, opposite is H. Hypotenuse is A. So sine of angle B is equal to H over A. So we now have our two trig ratios for our sine function. Now, what I'm going to do is I'm going to go ahead and solve both of these equations for the variable H. I want to get H by itself. So to solve for H, within my first equation, I'm going to multiply both sides by our denominator, by B, and that will cancel out our denominator. Same thing with sine of angle B equals H over A. I'm going to multiply by the denominator. In this case, it's A. So this will give me H equals B sine of angle A, and H equals A sine of angle B. Now we should notice something here. They both have been solved for H. And since they're both equal to H, since they're both equal to the same thing, that means that they are equal to each other as well. So therefore, B sine of angle A is equal to A sine of angle B. Now that we've substituted in for H, and again, all I did here was I took this chunk, A sine of angle B, and I saw that it was equal to H. So therefore, I took that whole chunk and I plugged it in for H in our other equation. Now that I have them set equal to each other, I just want to get rid of the variable in front. So how can I get rid of multiplication? Division. I'm going to multiply both sides of this equation by A and by B so that they'll both cancel. Well, dividing by AB, on the left side the B's will cancel, and on the right side the A's will cancel. Well, what's left over after those cancel? Well, we're left with sine of angle A over A equals sine of angle B over B, which is the law of sines, which proves that the law of sines works. All right, our final question of the day. A fire is sighted from two lookout towers 20 meters apart. The angle from the first tower to the fire is 48 degrees. The angle from the fire to the second tower is 75 degrees. How far is the fire from the second tower? Now, I really like this question. I highly encourage you guys to study it up. Make sure that you guys study this type of question. You will see at least one of them. Whether that be on the test, reviews, practices, homeworks, you guys will see these on all of those. So make sure that you guys are ready for law of sines, word problems type questions. Now, first thing that we need to do is we need to draw a picture. In our triangle, we're going to have two vertices, two angles that are our towers, one angle that's our fire. So here it is. Go ahead and set this on fire real quick. There's our triangle. So from here, we know that the two towers are 20 meters apart. That's given to us. So the distance from tower 1 to tower 2 is 20 meters. The angle from the first tower to the fire is 48 degrees. So looking from the first tower to the fire, that's 48 degrees. And from the fire to the second tower, that would be 75 degrees. We want to know how far the fire is from the second tower, so this distance here. So I'm going to go ahead and call that distance x and label the rest of the information in our picture. Looking at this, we already have opposite angles and opposite sides, so I can go ahead and match those up for our trig function. So therefore, we're going to have sine of 75 over 20 equals sine of 48 over x. Cross multiplying will give us x sine of 75 equals 20 sine of 48. And of course, we're looking to get x isolated, x all by itself. So we're multiplying it by a number. The way that we can get rid of multiplication is division. So dividing both sides by sine of 75 leaves us with x equals 20 sine of 48 degrees over sine of 75. This is what we want to put into our calculator. Again, please make sure that you include parentheses. The most important parentheses is probably this one right here, because if you don't, then you'd be left with 20 sine of 48 divided by sine of 75. And that is not the same thing. So make sure that you guys are entering in those parentheses, or else you'll get the completely wrong answer on your calculator. When you enter this in on your calculator, you'll be given the final answer of the distance between the fire and station number 2, tower number 2 over here, as 15.39 meters, meaning whoever's in tower 2 better get out of there very quickly because the fire's right there. All right, guys, that is it for today. If you guys have any questions, please let me know. Other than that, have a great rest of your day, guys. Thank you so much.